So today we'll start AC network theorem. There is nothing new in AC network theorem, only the analysis part. Whatever nodal analysis, loop analysis, Thevenin's theorem, Norton theorem, whatever maximum power transfer, whatever you have learned.
मेरी क्लास चल रही तो अब फालतू में ना झूठ मत बोला कर और कुछ भी मत बोला कर
Please
मेरे
mute yourself.
क्यों नहीं थी देना तो कौन कहना थी दे एक दूसरे तो क्यों दी थी
Please mute
ये
yourself.
मजाक तो कर रहे हैं तो फालतू झूठ क्यों बोल रहे हैं फालतू में बदनाम करते रहते हो मेरे को पढ़ने दो कंजरी
I hope she muted herself. Okay. So all the nodal analysis concept, loop analysis concept, then your Thevenin theorem, Norton theorem, all the theorems are valid, only the resistance will be replaced by your impedance. Okay. So with that in our mind, we'll just go through a few problems with which it will be clear to you. Just we need to take the help of complex algebra and polar to rectangular, rectangular to polar conversion. With that you can easily solve it out. Okay, so let's start first with a problem on nodal analysis of AC circuit. Okay, say we have a 2 ampere and angle is here not only 2 ampere, it is 2 ampere angle 0 degree current source. Okay, then that means it is 2 plus j 0. Then you have a resistance which is 1 ohm. You have a inductance, inductance of reactance J2. Then 0.5 ohm. Then there is a capacitor of reactance XC is equal to 1 by J5, say. This is a resistance of 2 ohm, and that too with the capacitance XC equal to 1 ohm resistance, that is in parallel with 1 ohm inductance. Reactance of the inductance, inductive reactance, we can call it in the other way. There is another current source which is of 1 angle 30 degree ampere. So if this is a circuit, how you can solve using nodal analysis? So as you can see that when there is more number of current source, we can uh, do it just by nodal analysis because things will be easier. So how many nodes we can identify here? Here we have one node like this. This is one node, node 1. This is node 2, and this is node 3. So you can put the node voltages at V1. Here it is V2. This is V3. Okay. So if we can calculate V1, V2, V3, then we can calculate all the branch currents. So to start with, first we should do the nodal analysis at node 1. Current is incoming and we are assuming these are outgoing from here. So 2 angle 0 is equal to what? V by 1 plus V1 minus V2, because current is flowing from V1 to V2, divided by J2, right? This is at node 1. At node 2, what we can write at node 2? V1 minus V2 divided by J2, that is equal to 1 angle 30. Because of this current source is outgoing, then V2 divided by zero point 0.5 plus 1 by J is in the denominator, mind it. V2 by this, then V2 minus V3 by 2 plus 1 by J2. So this is one equation. We can write it like, uh, anyway, that solution will do later. Uh, we'll just put it as this 1 angle 30, that you can change from polar to rectangular. So for that, what to do? We'll take polar command in calculator. So polar 1 comma 30. Oh, sorry, it should be rectangular to polar. So we should take first rec, then 1 comma 30 degree. So that is equal to it is 0.866 plus J into 0 0.5. Okay, so we have converted from polar to rectangular thing, and then here we can write it as V2 by zero point 0.5 minus J 0.2, isn't it? And here V2 minus V3 divided by 2 plus 2 minus J 5. Okay, sorry, zero point 0.5. So this is how you can get the second node equation. So next is the final one, node 3. So here what are incoming? V2 minus V3 in that way. So we can write V2 minus V3 divided by 2 minus J 0.5 plus angle 1 angle 30, which is 0.866 plus J 0.5 is equal to, these two are incoming and outgoing is V3 by 1. So V3, then V3 by J. So you can write it as V3 1 minus J. Okay. So these are your three equation. Equation 1, this is angle 2 equal to 0 means it is 2. So this is equation 1. This is equation 2. And this is equation 3. So once you have these three equation, then next is to make it more simple and you can get the overall expression. So you just rewrite your equation 1 as V1 plus, it is if you take 1 by J2 as minus zero point 0.5, then that you can write it as minus 0.5 J into minus 0.5 into V1 plus J 0.5, sorry, J 0.5 into V2 is equal to 2. So ultimately you can write it 1 minus J 0.5 or 0.5 J, whatever the way you want to write it, V1 plus J 0.5 V2 is equal to 2. This is your equation 1. This you can again revise and you can write it as minus J 0.5 V1 plus J 0.5 V2 is equal to 866 plus J 0.5. And then here also you can find out with complex conjugate. If you do that, then it will be root over, or here another way is to write in terms of, here rectangular thing you can change it to polar, right? You can write like this, then your calculation will be easier. So just you take from rectangular to polar, so you take polar and then you enter zero point 0.5, then comma, then minus zero point 0.2, then you will get your value, which is 0.5385 angle minus 21.8 degree. So once you take the inverse of this will be nothing but V2 into 0.538 plus 21.8 degree. Again, if you convert from polar to rectangular, then your things will be easier. So in the same way, this side you can write V2 minus V3 equal to, you do this and you will get your answer. So in that way you keep on solving, and then you will get your equation V1, V2, V3 equal to something. That equation you will get in form of complex quantity. So you will get a matrix of complex quantity, and then you can solve like the way we solve using matrix analysis, or you can do manually and then solve it. Okay, so this is a complicated one, but in your exam definitely this much complicated will not come. Little bit lesser calculation kind of thing, maybe two node can come, which you can solve at a step. Okay, so then this is how you should solve it. Here you are no need to draw the phasor diagram, then you will be puzzled actually if you want to draw with phasor diagram. Okay, so this is one example of nodal analysis. Let us now
Sir,
take
one
one.
thing. Sir,
Yes.
how this thing in denominator is coming in numerator, which you have written in the last 0.5 minus
uh,
j into.
mhm.
So beside this calculation, you have written in the rightmost V2 into 0.538 angle 21.8. How?
Because it is in denominator, when it is 20 minus 21.8, when you take inverse of that, that will be plus 21.8. Let me show it how it is. If you have r angle theta, that you can write in the complex way at r cos theta plus j into, oh okay, I have not put this zero point 0.5 should be inverse.
Yes, sir, that is the thing.
Uh, uh,
Angle
uh.
thing.
Okay,
Acha,
yes,
that
that
inverse.
is inverse.
Yes.
So this one you know, then I don't need to explain, is it? J sine theta,
Yes,
and then if you
yes,
take
sir.
inverse of that. Okay, okay, so let us now take another problem where we can do a loop analysis. Let me take out one problem where loop analysis is carried out. Okay, so if we do it, if I solve Thevenin theorem, there only we can use loop analysis. We take one problem uh, to solve using Thevenin theorem. So this is the problem. Let me draw it out. This is the AC source. Here it is Z1, which is 3 plus J4. That is your impedance in ohm. This is impedance. This is inductive reactance. This is capacitive reactance. 10 ohm. You have to find out current through 10 ohm resistor using Thevenin, and verify with Norton, say. So if we try to solve it, then what is the first step? As per Thevenin theorem, you should take out the load resistance from here, and then you should find out your open circuit voltage across these two terminal, which is say A and B. So I just take out this, and we should take the drop at this voltage. So we can do it by loop analysis, we can do it by nodal analysis. For me, I feel it will be much easier if we take nodal analysis, because these two are in equipotential. So we can take the, because there is no resistor, so we can take a voltage like node voltage like V. But I don't want to do that. Let me do it with loop analysis only. Let us take another impedance here, which is say uh, mm, 8 plus j6 ohm, like that. So this is another thing, this is another thing. So now we'll apply loop analysis, and then see how we can solve loop analysis the same way. So we'll take loop current, which is I1 here, this is I2 here. Okay, so if we can find out I2, then drop across this capacitance will give you the voltage across the terminal A and B, right? So let us do that. Then what is your first KVL equation? It is 100 angle 45 minus I1 into 3 plus J4 minus I1, sorry, I should write it like, it is I1 minus I2 into J10 equal to 0, right? In the next equation, we can write it as I2 minus I1 into J10 plus 8 plus J6 into I2 minus J10 into I2. This is open circuit, so no other current than I2. So it's like that only, equal to 0. So then we can rewrite this as uh, sine 45 and cos 45, there will be 0.707. So 70.7 plus j 70.7, that will be your this expression. So we can write it as I1 equal to 3 plus j4, and then this j10 will be added up. So 3 plus 14 j I1 minus j10 I2 equal to 70.7 plus j 70.7. Okay, so this is one equation, and then other one here we can write I2 equal I2 plus j10 plus 8 plus j6 minus j10, this, and minus j10 I1 is equal to 0. So from here you can either replace I1 or I2. So how can you do that? This will be, if you just rewrite, it is turned out to be equal to 0, right? So you can express I2, because it is I2 which we are interested to find out, that is equal to j10 by 8 plus j6 into I1. Agree? So J10 we can write 10 angle plus 90. Then 10 cos 90 plus J into 10 sin 90. So it is J10. Okay. And this one we can find out to be, we'll convert again from rect to pole. So we'll select pole, then we'll put the value 8 comma 6. So that turns out to be 10 angle 36.87 degree. So this 10 and 10 will cancelled out, and we are left with what? 1 into angle 36.87. So we can write it is simply whatever be the value of I1, on top of that you have to put this angle. So it's supposed to be I1 into, okay, it's my mistake. It's not 37 6 point, it's 90 minus that. Okay, so we should write it as 90 minus 36.87. That that comes out to be just a minute. Here it has come. So how can I change it to fraction, Sriman? Just a minute. Hold on. This is storing, no? Okay, so it's supposed to be 1 angle 53.13. So then you will get it as I1 into, we can write it as, again we'll change it from shift, from now we'll change from polar to rectangular, then it's supposed to be rec 1 comma 53.13, that is equal to zero point 0.6 plus j 0.8. So once you know I1 equal to I2 equal to I1 into this, that you can substitute in this expression. So 3 plus j 14, this is 14, and I1 I2 is equal to I1, na? That is what we have written. I should have written in terms of the other way around actually. So I1 in terms of I2. Anyway, let us do it once we have done it. So we can put it as I1, and then J10 into I2, we can write it as 0.6 plus J 0.8 into I1, that is equal to 70.7 plus J into 70.7. So now let us, we can solve it. J, then here it is minus j 6, and minus j square means plus 8 I1 equal to this. So what else we can write here? This is j8 I1 plus this is 11 I1, that is equal to 70.7 plus j 70.7. So again we should, from here we can solve it, what is your I1, and for that we need to take the help of again rectangular. So if we do that, then I1 supposed to be, let me write it in terms of what we are getting, 70.7 plus j 70.7 divided by, this is 11 plus j8, and then we can find out I2. I2 is equal to 70.7, this thing we can be written as 145 degree divided by 11 plus j8, and then that should be multiplied with zero point 0.6 plus j 0.8. And once you can find out I2 like this, then you can find out what is the drop across this. This is I2, so drop across this will be I2 into j10. So your drop VAB is equal to j10 minus j10 rather into minus j10 into I2. So minus j10 into I2, we got it in terms of this. So it is 100 angle 45 into 0.68 plus j 0.8 divided by 11 plus J8. Okay, so you can solve it now. This is 10 angle minus 90 into 100 angle 45 into this supposed to be 1. Some angle will come which is 0.6 comma 0.8. So angle is already we got it. It is 53.13 degree. So all these things will be multiplied and this is to be added up. And here for the other one below, what is there in the denominator, we should take again polar, then 11 comma 8. It is 13.6 into angle 36 degree. So what is your answer? It is 1000 divided by 13.6. So it has come out to be 73.53, and angle will be what? It is minus 90 plus 45 plus 53.13 minus 36. So that is equal to minus 27.87 degree. So this is your VAB. One answer you got it. Then you have to find out your RTH. So to find out RTH, you have to uh, uh, get the parallel combination of uh, all these impedances. So for that, what to do? Let me draw it again. It is 3 plus J4. Your voltage source will be shorted out, and then it is in parallel with J10, and then you have another resistance impedance of 8 plus J6, that is parallel J minus 10. So this is your RTH, right? So that is your internal resistance. So what will be that 3 plus J4? This is parallel with J10. So first you have to solve that. So it is J30, sorry, plus J30 minus 40, isn't it? J square equal to minus divided by 3 plus J14. So you need to solve it. It takes a time to solve because every time you have to change from polar to rectangular, rectangular to polar. So angle minus 40. So not, it's not angle, it's a imaginary part. Oh no, I have taken the other way around. So we'll take polar, then we'll take minus 40 comma 30. That is equal to your 50 angle 143.13, and below it is to be, we'll take polar, then 3 comma 14. So this is 14.3178 angle 77.9. So 78 almost we can write. So once you have this, then you have to again convert it into once you solve it, 50 minus 14.3178. So this is 3.5 angle 143.13 minus 78. So this has come out to be 65. Again you convert this into rectangular because you have to add it with this part. So for that we'll take 3.5 comma 65.13. So this is 1.472 plus j into 3.175. Okay, so once you have that, then this is to be again added with 8 and all. So once you add the equivalent part of this, and then if you add it, it will come out to be 9.472 plus j into 9.775. Okay, so this again is to be, yes, hello.
What we have, yes, sir. What we have to add then after it?
You have to add, you have this parallel combination now that has come out to be this. So that is its series with 8 plus j6, right? So then you need to do that. Otherwise, you how can you
Yes,
find out
yes,
the solution of these two?
yes, sir.
Okay, so I have added this with this. So now the effective branch has changed to this value. This is your impedance, and that is in parallel with the minus j10. So you can write it your RTH to be equal to, now you multiply this, so this will become minus 97.75 plus minus this will be plus because j square and then minus, so plus 97 minus j 94.72. So this is in the numerator, and denominator we should add it up. So we'll get 94.72 minus j, very small quantity, so it is supposed to be 2.3 something, 0.23 something. So we can almost ignore that. Then if you again change it to polar to rectangular, you will get the value. I am not doing it. I hope you can understand what will be your RTH now. So you know what is your VAB, what is your RTH. This is your VTH actually. So you have calculated VTH, you have calculated RTH. Next step is to find out your I10, which is simply VTH divided by RTH plus 10. Okay. So it is better to put your RTH in terms of Cartesian coordinate only. So if we ignore this part, approximately we'll get the value which is in Cartesian coordinate. So it is 97.75 divided by 9.472. So this is 10.32 plus minus j into, this is j only, right? 10.32 minus j. So what is your VTH? Your VTH you got 73.53 angle minus 27.8 divided by RTH is 9.472 minus j, this minus j, and then plus 10. So it is 19.472 minus j. So again you convert this 17.53 angle minus 27.87. Then below it is shift polar 19.472, 19.472. Then on top of that, comma, sorry, shift comma 1 or minus 1. It is minus 1, no? Minus 1. So this is supposed to be 19.4. It is 5 actually, approximately, and theta is equal to minus 3 degree. So you get what? Your answer will be 73.53 divided by 19.5 equal to 3.77, and angle will be 24.87. So this is your answer. You can leave your answer in terms of polar coordinates. So this is your answer. Okay. So that is the value of I10. I mean the current through this resistance. So those who are from electrical or electronics background, for the streams of electrical and electronic students, it is very important to do this kind of analysis, and specifically for the electrical student it is very important in future. Okay, maybe in the circuit theory part you have to go through, you have to learn this again, and we'll now verify this with the verify the result with the Norton theorem. So for that, I'll just show you the steps. So how can you do this when you solve using Norton? Sometime this 100 angle 45, it can be written as sine 100 sine omega t plus 45. So don't get confused with that. Okay. This is your impedance, which is 3 plus J4, inductive reactance J10, impedance is 8 plus J6, na? Capacitive reactance, which is minus J10. So this is your A and B terminal. Earlier there was 10 ohm, now we'll short it. So this is your ISC. So to find out ISC, what to do? This will be anyway uh, bypassed your capacitive reactance. Then you have to find out your total current, and then you should use the current branching rule. That is also possible. If you want to use the nodal analysis, let us show it by nodal analysis. If this node voltage is V, then 100 minus 100 angle 45 degree minus V divided by 3 plus J4 is equal to V by J10 and V by 8 plus J6. So V by 8 plus J6 is nothing but your short circuit current, isn't it? Right? So if we can solve V, then we can find out the short circuit current by V by 8 plus J6. Okay, so we'll do this only. So 100 by 45, this is 5 angle, I forgot the angle, maybe 36 or something. So it is uh, polar 3 comma 4, it is 53.13, and this side it will be V by this. So it is we can write it as V into zero point 0.2 angle minus 53.17, isn't it? Because this is 5 by this, so once you take inverse of that, it is 0 0.2. Then this you can write it as V into here this is 10. It will, when you'll go up, it will be minus J 0.1, right? So you can write it as minus J 0.1 V, and then this is actually, this is 10 angle, uh, it's other way around, it is 36 something, let me check it. So polar 8 comma 6, so 36.87. So this also you can, instead of writing like this, you can straight away write as V into zero point 0.1 angle minus 36.87. Okay, so then it is easy. So you can get it. This is 20 minus, you can get this angle 53.13, and then 5 should somehow, it will be 8.13. This is 20, and then solve. If you can solve this, again you change from polar to rectangular, then you'll get all this expression. Then in that way you can find out the value of V, So you calculate what is your V, then find out V by 8 point this thing. So this is your ISC. So if you V is known, ISC equal to known, and then finally you know what is your RTH equal to your RN. RTH already you have calculated, that is equal to RN. So you can find out your I10, which is equal to your RN by RN plus 10 into ISC. So just cross check and verify. I'm not doing it. I'll leave for you to solve. So as I have shown that you convert the Cartesian to polar, polar to Cartesian, then only things will be smooth. Otherwise, you'll will be facing trouble when you'll solve if you try to do it manually each and every step. Okay. So let us show one. So Thevenin Norton we have covered, and one more problem we'll take from superposition. Okay, then all the theorems with AC will be able to cover. In circuit theory also, those who are from electrical or electronic stream, in circuit theory you have to redo all those things with more number of theorem in future in your I think in third semester. So as of now, any doubt? I got one problem. Any doubt as of now? No.
Sir, one doubt, sir.
Uh,
In calculator, sir,
hmm,
in calculator, I'm doing like for the parallel combination, I
hmm,
am writing impedance 1 inverse plus impedance 2 inverse.
hmm.
So, sir, in with different values coming, but if I'm doing it by like x1 into x2 by x1 plus x2, then different values coming. Sir, why it is happening like that?
Impedance inverse, impedance, if you add those two, you will get the effective impedance inverse only. No? Then you have to take inverse of that.
Acha, oh, sorry, I forgot to do that.
If you do that,
Thank
it
you.
will come. Okay, so let us now take one problem based on superposition. 5 angle 30. Capacitive reactance is given. Here, this is also capacitive reactance, inductive reactance. Again, here there is an inductive reactance, and this is another source. Okay, so we should take each source at a time and replace the other with its internal resistance, right? So then what to do? When we'll go first with the first source, then we have to replace the other source by its internal resistance. Then automatically your this reactance will be dropped out, right? Let me redraw it. You have to replace the voltage source by short circuit, internal resistance, and current source, ideal current source, by open circuit. So when we'll do that, we need to say it is told that find out the I missed out this one. This is a J3. So using superposition theorem, find I J3 ohm. I mean this one, this I. Okay. So then we should bypass this, and this should not be there. we'll take this only. So we can redraw it again. I'll just remove this source from here because it is a short circuit now. Okay, so then we should find out this. There is a simple current branching rule you can apply, right? So what will be the effective impedance is the parallel combination of these two. So J2 minus J5. So it is minus 10 divided by minus J7, isn't it? So it is ultimately minus J. This minus minus will cancel out. So minus J 10 by 7 comes out to be what? Let me see. It is 1.4285. Okay. So this is your effective uh, your no, I made a mistake. This 3 ohm again I missed out. Oh, okay. So it is how much then? Minus J5 plus J3 ohm. So it is again minus 2. So what will be the value? J2 into J2 by minus J4, right? So it will be what? It will be minus J, isn't it? So this is your effective equivalent resistance. So you can find out your I. This I is equal to 5 angle 30 divided by minus J means it is 1 angle minus 90. So you get what? 5 angle plus 120 degree. Okay, agree? So then what we are left with? Then once you can find out your I, this is not I1, this is I, or we can write it as I0. So then we need to find out your I2 because I2 is the current which is flowing through this inductive reactance. So your I2 is equal to 5 angle 120. Then will be there will be current branching rule. So it will be half only because it is same na. So here also it is minus J2. Here also it is minus J2. So it is minus J2 divided by minus J2 plus of minus J2. So minus of minus this. So then what you're left with 5 angle 120, then it is minus J2 divided by minus J4. So it will be 2. So angle is 2.5 into 120 degree. That is for this path, for the source this. And in the next step, what will happen? The next step you will replace the other source and will take 10 angle 60, and that time the capacitive reactance minus J2 will vanish. So we'll just redraw it. Minus J5, this is your J5, this is your source which is of polarity like this 10 60, then this is your J3, and then this 2 ohm will be minus 2 ohm will be ignored because we'll short it by its internal resistance. So once you have this, then your current will be flowing like this. So it is the other way around, isn't it? There it was flowing in towards this way. So these two we have to subtract anyway. So when we'll take this, what is your Z equivalent? It is J5 parallel to minus J2, isn't it? This is minus J2, this is J5. So J5 into minus J2 plus J3, isn't it? So this JJ will cancel out. So you are left with minus j. This is how much? 10 by 3. And it's supposed to be 3.33. Okay, got it. So uh, this is how we get your Z equivalent. So once you get that, we can write it as 3.33 angle minus 90. So what is your I0? Here I0 is 10 angle 60 divided by 3.33 angle minus 90. So that's supposed to be, it is 10 by 3, so it will come out to be 3 only, na? This is how much? It is 10 by 3. So here also 10 by 3, so it will come as 10 3 angle 150. So once you find this I0, next is to find out your this branch current, which is I2, and that I2 will be equal to 3 angle 150 into, using current branching, it will be J5, then it is J5 minus 2J. So it is again 15 by it is 15 angle 150, and below it is 3 angle minus 90. Oh no, it is plus 90 only, na? This one will be, no, I am making mistake. So J5, and then this is your effective thing, which is minus J2. So J5 minus J2, huh? Okay. So it is plus 90. So 5 angle 60. So now you should take the difference between two. So earlier it was how much? 2.5 angle 120. I2 is equal to 2.5 angle 120 minus 5 angle 60. And it is flowing. That polarity you should give. Okay. So you will get it as, if I change from polar to rectangular, 2.5 angle 120. So minus 1.25 plus J into 2.165 minus, here it is to be shift uh, rec 5 comma, let us write it as minus 5 comma 60. Uh-huh. So it is 2.5 minus 2.5 minus J into 4.33. So it is, comes out to be minus 3.75 minus 4.33 minus 2.165. So it is minus 2.165. Okay. So the whole thing you can write it as shift, again you change from Cartesian to polar. This is equal to, you can take minus common, then you can take 3.75, or you can take directly as uh, minus 3.75 comma minus 2.165. So it is 4.33 angle minus 150. Okay. So this is how you can solve the your AC network using superposition theorem. Okay, and you can expect a very elementary circuit, not a very complex one, to practice. For practice purpose, you don't need to go through a very complicated circuit. Try to solve with a small circuit, not very complicated ones from any book. If you ask, I'll later provide you a few exercise which you can solve. Huh? And don't try to draw here phasor diagram, and don't try to solve it from the point of view of phasor diagram here, because you'll be lost in that case. So it is better to always follow the Cartesian coordinate approach, Cartesian to polar, polar to Cartesian, that conversion, I mean, in the complex plane, and then it will be easier for you to uh, solve the circuit. Okay. So any query as of now? Okay, as you do not have any questions, let us close today's session.